Hello all, welcome to Public Cloud Design Tips and Tricks with a new topic, Service Mesh. In the subsequent session, we'll be discussing more on Azure Open Service Mesh and AWS App Mesh. So that's the reason why we thought of sharing the fundamental sessions on Service Mesh. Now, what is the problem statement here? The problem statement is how to get out of the box observability features for highly dynamic microservice environments. Now, what is a service mesh? A service mesh works always as a sidecar pattern on a container orchestration platform. So, what it does, it provides capabilities to make the microservices or the application secure, reliable, and observable. It runs in a platform layer, or it considers a platform layer as a decoupled unit from the real microservice or the application layer. Now, technically, these are nothing but network proxies components, okay? And it provides a communication channel between consumer and microservices. Now, how it looks like typically, if you follow the diagram, there are three microservices, service A, service B, and service C running in a container platform basically. And for each microservices, there are parallel sidecar proxies running. These are nothing but the service mesh actually. Okay. Now, how does it work? So, we already discussed a service mesh abstracts the logic that deals with service to service communication. So, here service to service communication means a microservice communicate with another microservice, or a consumer or an enterprise trying to connect to a microservice within a container platform. Okay. So, it always considers an infrastructure layer as opposed to individual services. Here services are microservices. Now again, it's an abstraction or set of network proxies run side to your application that we have already discussed. Now coming to how a typical web application looks like, there are two parties always involved, a consumer and a provider. So provider actually provides the APIs that needs to be consumed by the consumer. So here the provider is web application, and in a normal scenario or in a practical scenario, there is always a web proxy that sits between a consumer and provider. So what it does, the web proxy always deals with the routing logic and if require the necessary security logic inside it. So that is how it looks like. And normally a web proxy is nothing but a different software that sits between a consumer and a provider. So that is how it looks like in a typical web application scenario. Now, when you come to a container orchestration platform, so there are a lot of microservices, the green color MS, those are running actually that deals with the real business functionality. And for every microservices, you will have a sidecar proxy, which is nothing but the service mesh. Those are running actually parallel to that within the network boundary or the container boundary basically. Okay, so that is how it looks like. So, and that is how also you can relate how a typical web proxy looks like in a web application, whereas in a container orchestration platform, how a service mesh looks like. Okay. Now, let's discuss a little bit about the core concepts behind it. So the first one is how it gets operate. We already discussed it always run in parallel to the microservices as a sidecar. Okay. Where does it work? It always run to each pod, okay, and communicate with each other to route the traffic between the containers they run with. Okay. So it always run inside a container platform basically. Now, what are services here? Services are nothing but the microservices that runs in a container platform within a pod, you can say. Now, when a microservice try to communicate with another microservice, there is always a discovery pattern runs behind, and here it's a DNS lookup services that helps to communicate across microservices. Okay. Now, typically, when it comes to load balancing, a orchestration platform, it typically provides the transport layer load balancing, which is nothing but layer 4, whereas a service mesh provides load balancing on the application layer, which is layer 7. Now, what is encryption? So whenever the service mesh gets the request, then it has the capability of encrypt or decrypt that request. Okay, so that is also very well done within the service mesh layer. Now, also it can deals with authentication and authorization. So the logic to authenticate and authorization can also be written in the service mesh just to abstract it out from the application layer. Now, it is based on circuit breaker pattern as well. So service mesh enables isolating unhealthy instances and bringing them back gradually if required. Okay, so that is the fundamental of circuit breaker pattern, and that is also applied to a service mesh. Okay, so service mesh is based on that pattern as well, you can say. Now there are two fundamental components that involved in a service mesh topology. Is one is data plane and the other one is control plane. So in a service mesh architecture, a data plane refers to proxies basically, which is the sidecars. Those are responsible to handle and route the request. Okay. The communication to and from the services go via the proxies. Now it also handles authentication and authorization that we already discussed. And it also handles load balancing, encryption, logging and tracing, rate limit, etc. Now again, the same thing, it decouples the application logic from network communication logic. It helps developers to focus more on building microservices, okay, uh, rather than thinking about the routing and other related stuff which can be deal with the sidecar or the service mesh proxies. Okay. Now, coming to the control plane. So basically the control plane refers to provide APIs to control proxies or data plane. Okay, so proxies are running within a data plane we discussed. So how to control that or how to manage that from a control plane. Now each proxy of data plane should be registered with the control plane. So let's say there are 10 proxies that is running in the data plane area, that should be registered in the control plane for management perspective. Now it also defines policy and configuration to be created for proxy management. Okay, so these are the responsibility of a control plane. So in a typical scenario, if you try to access the data plane, then you always use the control plane using the CLI. So user can use CLI command. For example, a config API that in terms we talk to the APIs that is responsible to connect to the data plane, and finally that changes happen within the data plane on the sidecars or the proxies, service mesh proxies. So that is how it works. Okay. So there are a lot of articles or documents available in internet on service mesh. Please go through to have a better understanding on this topic, so that we can continue with our public cloud related service mesh capability in our subsequent session. That's it for the day. Thank you and have a good day.